Yes, hello everyone. So let us discuss the concept of uniformly accelerated motion. That is the case, that is the topic that we're discussing with this video. So, uniformly accelerated motion, already studied in the ninth grade. You have discussed, you have understood this formulas. V is equals to U plus AT, S is equals to UT plus half AT square, and V square minus U square. Okay, V square minus U square equals to 2S. The only important thing for me to tell you here is that the V and the U represent the initial and the final velocity. Remember, velocity, not speed. The A represents the acceleration and S represents a displacement. The important point for you to understand, except for the time in this formula, everything else is a vector quantity. That means when you're using this formula, please be very careful with the direction. That means the sign that you use here. Okay, as simple as that. So if you're considering the right hand side to be positive, then the left hand side should be automatically negative. Accordingly, you should be using the sign convention. If you are taking care of that, everything else is okay. Now in this topic, there is one more formula that you require, that is the distance traveled. Okay, distance traveled in nth second. They ask at times questions based on this. So what's the meaning of nth second distance travel? Let us say the particle starts from here and the particle moves in this direction. Okay, so time t equal to 0 is here. The particle just started. After some time t equals to n seconds, the particle is, let us say, here. Before that, at time t equals to n minus 1 second, the particle was here. And after this, at time t equals to n plus 1 second, the particle would be at this position. When they say find the distance traveled by the particle in the nth second, what they're trying to ask you is find the distance traveled by the particle between the time interval of n and n minus 1. Very important. Okay, don't confuse here. So when they're asking you to find out the distance traveled by the particle in the fifth second, for example, then they are actually interested in distance travel between the time interval 4 second and 5 seconds. Okay, similarly, if they are asking you to find distance travel in third second, they are asking you to find out between 2 seconds and 3 seconds how much distance it has traveled. So if they are interested in this distance, can I just simply say it is nothing but the subtraction of the displacement that has happened for n minus 1 and displacement that has happened for n. This is displacement for the n minus 1 time, and this is displacement for the n time. When you do that, that is displacement of nth second. Okay, I should actually change this, because this question, all the formulas are based on vector. So we are not actually finding distance, we are finding actually displacement. Sorry, we are finding actually displacement. So displacement in the nth second is nothing but displacement in n seconds minus displacement in n minus 1 second. Displacement in n second can be written as ut. T is nothing but here what? N. U into n plus half into a into n square. I'm using the second formula. Okay. And minus, here it will be u into n minus 1 plus half into a into n minus 1 whole square. If I open the bracket, I'm pretty sure you understand. Here I have a un. Here I'll be having, opening the bracket, minus un. They get cancelled. Also, I'm having half a n square. If I open this bracket, I'll be having there also half a n square, but with a negative sign because outside, so it will get cancelled. So now what remains inside is nothing but minus u, which comes out as plus u, and then minus of, inside this bracket, what pending is nothing but half a into the brackets pending term would be minus of 2n plus 1. This term would be pending. So when I open the bracket, what I'll be getting is u uh, plus an, and then this would become minus of 1 by 2a, right? This is what I'll be getting. So finally I'll be getting the displacement in the nth second would be nothing but u plus a times n minus 1 by 2. This is what we get as the displacement that has happened in the nth second. Try to memorize this formula just like you remember these three, because in exams they will be asking you questions based on this. Okay, fine. Once we have understood this, then we can move on to a question. Okay, so look at the question. I'll be showing you one question now. Okay, yeah, let's solve this question. So look at the board. You will be seeing this question. A particle moves in a straight line with constant acceleration. Okay, if it covers 10 meters in the first second and 20 meters in the in the next second, then find its initial velocity. So they have said that a particle is traveling 10 meters in the first second, and in next second it is traveling 20 meters, and it's a constant acceleration. So particle, let us say, started from here. This is the question that we are doing. Particle started from here, it is going in this direction. In the first second, that is from t equal to 0 to t equals to 1 second, it has traveled a distance of 10 meters. In the next 1 second, that is t equal to 1 to t equals to 2 second, it has traveled a distance of 20 meters. Then what is the initial velocity? That's the question. So because they are interested in the initial velocity, I will try to take two time intervals. I'll try to take the interval from t equals to 0 to t equals to 1 second to form one equation. I will also take another interval as t equal to 0 to t equals to 2 seconds. In both the cases, I am always taking from t equal to 0. I hope reason is clear, because they want velocity at t equal to 0. Now from the given question, what all things are given to us, please understand. Displacement, so s is given, time is given, and initial velocity has to be found out. So don't you think that we should be using the second formula, that is s is equal to ut plus half at square? So we'll use that formula here. S is equals to ut plus half at square. S value, displacement 10, u value no idea, t is 1 second. So can I just call it as u, because t is 1, plus half into acceleration no idea, 1 square, again 1. Okay, so this is my equation number 1. Same way, if I use the formula s is equal to ut plus half at square in here, this time the displacement is nothing but 20 is my displacement, and u again unknown, but time is 2 upon 2u plus half into a no idea, 2 square, 4. So this time I'm getting the equation as 20 plus 2u plus this, cancel this value, divide this by 2, we'll be getting the answer as 10 equals to u plus a. This is my equation. So this is my equation number 2. Because they are interested in finding the u value, I should substitute the a value in this equation. So what will I get? 10 is equals to u plus half into a will be substituted as 10 minus u. So this would give me 10 equals to u plus 5 minus u by 2. 5 can come this side. 5 is equals to u by 2. U is equals to 10 meter per second. That becomes our answer. Right? Simple. Now, just like this, in the same question, we can find some more data. Like for example, if I continue with this question further, they are asking you to find acceleration of this particle. Because I know the velocity, initial velocity I am aware of, can I now find the acceleration? What should I do? Just substitute this value in, let us say, any one of this equation. I find this equation to be easy. Substitute that there. What will I get? 10 is equal to u, which is also 10, plus a. Okay. While calculating, I am getting it as u by 2, 5. Yes. So if I substitute the value of velocity here, am I getting the acceleration as 0? Why is that happening? I think I might have done some calculation mistake. Let us just check that. Did I substitute everything properly? Ah, yes. See, the mistake is pretty obvious. What is this value? This is the displacement that happens in the 0 to 2 seconds. And what is 0 to 2 second displacement? Isn't it 30? It should be 30. If this is 30, then this value would be 15. Now, change that, right? This is 15 by minus u. So this would become now 15 by 2. So this would give me u by 2 is equal to, it comes this side, I'll be getting what, 20 minus a 5 by 2. Huh? Yes, I'll be getting it as 5 by 2, and finally my answer will become 5. See, mistakes. I just keep repeating that. Okay, so I'll be getting that value of u as 5 meter per second. And now if I substitute that there, I'll be getting the acceleration as a is equals to 5 meter per second square. If you are also a person like me who keep making mistake, then always be careful while calculating. The only way to avoid the mistakes is staying more focused while solving the question. Okay, so right now for me it's okay, I can correct it, right? But for you in the examination, it's not possible. So just keep focusing more. I am also just trying to avoid my mistakes by doing the same thing. When I used to be studying, I used to make much more mistakes. Okay, silly mistakes like this. Think about this. What kind of silly mistake? I drew everything properly, but I substituted wrong. I'm pretty sure that all of you are also experiencing the same. Try to minimize that by focusing while doing the question. Okay, you have to focus more while doing. After completing the question, recheck it once again, because you are very confident that you will make mistake. I am very confident that I will make mistake. So I should be always rechecking the question so that I make sure that I eliminate as much as possible the mistakes. Okay, so this is one case. One more extra thing we found, acceleration. Another extra thing that we can find is find the velocity of the particle at the end of the third second. Velocity of the particle at the end of the third second. I want velocity at the end of third seconds. Don't you think this formula would be the apt one to use here, right? So I can use that formula. I can say v is equals to u plus at. I'll use. How much time we are talking about? At the end of third second, not at 3 seconds. So we can say u, initial velocity is 5, acceleration is 5, time is 3. So from here I'll getting 15 plus 5, 20 meter per second. This is the answer for the next question, that is velocity at the end of the third second. Okay, next one, displacement of the particle in 3 seconds and displacement of the particle in third second. Displacement of particle in 3 seconds can be found out as formula S is equal to ut plus half at square. This is for displacement of the particle in 3 seconds. So substitute the initial velocity 5, time is 3, plus half into 5 into 3 square. So this would be 15 plus 9, 5, 45, 45 by 2. This would give me 30 plus 45, 75 by 2 meters. This is the displacement that has happened in 3 seconds. But what if they ask specifically third second? Okay, so I should be saying displacement in the third second, which is this one, right? So I should be writing the formula as u plus a times n minus 1 by 2. And what is the n for our case? I'll just write this as nth. Okay, so now I'm substituting third. So what should I put now? U, initial velocity as 5, plus acceleration also has 5, n value third second, 3 minus 1 by 2. So what do I get? 5 plus 5 times of, that will become 6 minus 1, 5, 5 by 2. So this will become 25 by 2. So 5 plus 25 by 2, it will give me 35 by 2, right? 35 by 2 meters. This becomes a displacement in the third second. So let us make sure that calculations are correct. You can also check it. 5 plus 5 into 3 is the time, third second I want, minus 1 by 2. So 6 minus 1, 5, 5 by 2. Yes, 25 by 2, it will become 10, 10 plus 25, 35, 35 by 2. That's it. So these are different ways of finding the required data for acceleration, uniformly accelerated questions.